68 to 90, 10-4.
Attention FDIC attendees, in just a moment in the IDEX Fire and Safety booth 1608, we're going to host a presentation by Dalan Zartman, longtime career firefighter and the lead of Energy Security Agency. He also serves as a rescue specialist, training firefighters and rescue groups around his region of the U.S. He will be presenting on extrication challenges of electric vehicles. Let's give our attention to Mr. Dalan Zartman. Dalan.
Thank you. I think I got this close enough. Thank you very much. I'm going to try and do two things at once with two hands. We'll see how this goes with the clicker and the microphone. We're going to try and keep this very compressed and focused, but I want to make sure that I give everybody some tangible walkaways leaving this brief presentation so that you got good tools in your toolbox regarding some extrication concepts as they relate to electric vehicles. To get there, I think the most important foundation to start with today is to just basically understand lithium-ion batteries, how the voltage systems are oriented, designed, and what they do and don't do in vehicles, so that'll kind of build the foundation for us to understand what the trouble areas are on vehicles when we're performing extrication and how to avoid those or properly manage them, okay? Let's see which way I'm supposed to point this. All right, so to begin with, there are a variety of types of electric vehicles, but there are certain components that are present in all of them. This is an all-electric vehicle, or what we call a battery electric vehicle, and it just gives us kind of a basic grid of where parts and pieces are. 10 years ago, when the HEV world of education started, we had two big teaching points, and it was don't touch the orange cable and don't touch the high-voltage battery pack. I'm sure everybody recalls those days. We're really trying to reframe that educational point and say it's not just about those two elements. This usually resonates with firefighters, and this is to communicate, think of every electric vehicle as a circuit, right, or a system. This is an electrical circuit, and every single piece of equipment that is part of that circuit is a point of concern, right? So as we look at this and we evaluate what's on here, we've got our high voltage traction battery pack. We're going to have a plug that's coming in, and these can be a variety of levels of plug capability and charging capabilities. We're going to have high voltage cabling coming off the traction battery pack. We're always going to have an electric traction motor. You may have a singular motor in the front, you may have a singular motor in the rear, or you may have two motors. On the new GMC Hummer, you actually have 4 independent motors on each wheel. So there is no, continuity within the world of EVs to say motors are always going to be here and motors are always going to be there. As you look at all these other components here, today is not a day where we're going to explain what all these things do. DC to DC converters, thermal systems, your onboard charging system, your auxiliary battery, your transmission component, your charge port. What we are going to explain is every one of these are potential hazards. So some of the common moves we make, fender crushes, A-post cuts, every one of those elements require either you to look and understand, is there an electrical component connected to that? Okay, and it can be any one of these features or not. So you need resources at your tips or at your fingertips, or a whole lot of academic study to try and discern where these parts and pieces are. Okay, this also radically affects our ability to put the vehicles in a safe state. It is not the same across the board for every make, model, and year of vehicle. So everybody's becoming familiar with cut loops. Yes, cut loops are going to do different things on different cars. In their purest explanation, they are designed to isolate high voltage energy to the traction battery pack and potentially the high voltage cable. Some of them will also interrupt power for your low voltage system. So it's very important that you understand when you're going to cut a cut loop, if you're going to cut a cut loop, how it's going to impact your overall operations. Your 12-volt system is always going to control your transmission and your SRS components in many cases, right? So we'll just paint a picture for you. You've got a moderate collision You need to gain access or control that vehicle, and you want to push it off the roadway. If you disconnect the 12-volt battery, you lose the ability to affect the transmission of the vehicle. Everybody tracking that? The second challenge on a lot of EVs is you have electromechanical switches, levers, and handles. So just getting into the frunk or the front trunk space, opening up the door handles, all of those systems on many of the EVs are linked to 12-volt power. So the days of being the every time, all the time as firemen, we just engage the vehicle and cut the 12-volt power. You got to think twice about that now on EVs. You got to understand how that's going to affect your operating sequence and whether or not it's a move that you want to make or don't want to make. So quit thinking high voltage cable and traction battery pack and start thinking comprehensive system. Any parts of this system that are damaged or that you may potentially cause damage to with extrication tools can result in really bad things, which we're going to start to work into now. All right. Now let's talk about batteries. I like to explain this as though we're making lasagna in a casserole dish, okay? And I don't have enough time to get really, really heavy in the chemistry on this, but I want everybody to understand the base level on this. If I'm going to build a lithium-ion battery, I'm going to take a layer of noodles, for lack of a better term, okay? And we're going to call that first layer of noodles an anode. There's two terms we're going to use, an anode and a cathode. Anodes and cathodes just represent basically a positive filament and a negative filament, meaning one of them has certain chemistries, designs, and coatings that's designed to discharge lithium ions. The other one has components that are designed to charge lithium ions, okay? So I lay in this layer of noodles, and let's say it's an anode. My next layer would preferably be the cathode, which is the other side of that equation, so I can move these lithium ions back and forth. The problem with this is when I place that other layer of noodles down, those two layers don't like each other, okay? Anytime they come into contact, they're going to short circuit, all right? Here's the other problem. To help facilitate the movement of those lithium-ion particles, what do I put between lasagna noodles? Sauce, right? I put some sauce in there. Well, the sauce in lithium-ion batteries is an electrolyte gel, paste, or liquid that has organic solvents in it. All of you as firemen, as soon as I say organic solvents, you're going to recognize, oh, that means flammability, right? So now I've placed a paste, liquid, or gel in between these two layers that don't like each other. And if I create a short circuit by those two layers contacting each other, that flammable solvent is going to heat up, build pressure, and then eventually rupture the battery and off gas, okay? So I slip one more magical element of noodles in between the anode and the cathode, and it's called a separator. A separator is polyethylene or polypropylene. Think of it as just a thin piece of mesh, for lack of a better term, and that material lets the lithium ions move back and forth, but it protects the anode and the cathode from ever contacting each other. So that's kind of the best fireman terms way I know how to explain the chemistry behind lithium-ion batteries, all right? Now, let's talk about how they get conformed. If you look at this in detail, you see it's everything we just talked about, right? We have anodes, we have cathodes, we have separators, we have gel in between all those layers. If I want to make a cylindrical battery, then I take that layer of noodles and I roll them up. Once I roll them up, I place them inside of an enclosure, and that's my cylindrical battery. Prismatic batteries, predominantly found on much of your European imports, your BMWs, your Mercedes. Same concept, but I'm going to fold up those layers of noodles, and I'm going to slide them into a rigid metallic case, okay? And then I can also have pouch cell batteries. Pouch cell batteries are like metallic envelopes where I'm slipping all those same layers of material into the equation. The last one is button cells. Everybody's probably familiar with button cells because they think of watches and small appliances. But what I want everybody to understand about this slide is you may interact with every single one of these on one vehicle. Okay, so what you need to understand is you may have cylindrical cells in your traction battery pack or the battery pack that's built into the floor pan of the vehicle. Your low voltage battery on the newer EVs are no longer lead acids. They are moving towards lithium ion low voltage batteries that are not recognizable as standard lead acid batteries, and many of those have prismatic lithium-ion batteries in them. Recent event happened out in California, had a recycling center, fully removed a traction battery pack from a vehicle, did all their protocol checks, took that vehicle, put it into a crusher, removed it from the crusher, placed it on the sled with all the other crushed cubes. It caught on fire. because of a lithium-ion-based fire, caught all the adjacent things on fire, ended up burning 30 acres of wildland property. And the source of that fire was the low-volt lithium-ion battery. Everybody follow that? So even the little guy can get you. The button cells are located in key fobs. Okay, so your key fobs can create problems for you. So be prepared to engage every single one of these. Now, this is the part that can get confusing for everybody with terms. So I'm going to use ESA terms to help everybody understand how these things get put together. Everything we just looked at is what we call a cell. Okay, so it's a singular cell. When we build car batteries, we take cells and we place cells into what I call cell packs. So if you look at this slide, the small black component here with the silver tabs on it, that would be an anode and a cathode silver tab. What we do is we take that box that may be about the size of a VHS tape, and we literally cram as many of those cells into that box as we can. Those could be prismatics, those could be pouches, or those could be cylindricals. Then we want to run wire leads off of those anodes and cathodes, and that gives us our positive and our negative tabs. Then I'm going to cram as many cell packs into this box as possible, and this is called a module pack. Then I'm going to take module packs and I'm going to throw them into what's called a battery pack. And you end up with what's in a modern day electric vehicle. Okay. Now let's talk about the real world challenges as extrication people now that we understand these batteries. There are three things that lithium ion batteries don't like. They don't like thermal abuse. They don't like mechanical or physical abuse, and they don't like electrical abuse. All right. So let's just talk about wheel rotation. When the vehicle is off and you move the vehicle and the wheels are rotating, that is spinning the electric motor in the opposite direction, which means it is backfeeding voltage into the high voltage battery pack. Okay. Just by show of hands, did everybody think that's going to be a problem? Yes. Okay. So when we categorize, batteries don't like electrical abuse. When electricity comes into the traction battery pack in a speed or a volume that battery pack doesn't like, that creates heat. Heat generates a boiling process within the electrolyte gel, which builds up pressure, which creates off-gassing, which then results in what we call thermal runaway and propagation. Let's talk about mechanical or physical damage. That's your collisions, right? Or any penetrations to the case, any tweakings of the battery enclosures. Also, physical contact and damage to the components. When we're looking at this as a circuit, understand there's safety systems in here that are designed to open that circuit in times of collision. But when you damage elements of a vehicle in a high-speed collision, a lot of those safety features don't work. So you may expect the vehicle to be isolated or automated in a shutdown procedure, and it's not, all right? So always assume the vehicles are energized when you are engaging them as extrication personnel. What about submersion? Submersion is a spinoff that ends up creating electrical damage, but it's more of an environmental equation. Anybody worried about getting electrocuted by an electric vehicle in a pond? You shouldn't be, okay? Don't worry about that one, right? This is direct current, not alternating current. We're talking about two totally different applications. We can't dig into that real deep today, but the only time you have a really high energy hazard related to EVs is when you're directly interacting with the high voltage battery pack or the high voltage cable itself, or the superconductors that may be connected to generators. The best way for me to explain generators to help you guys understand all these confusing terms is on the wheels. Many of the vehicles will have what we, just for lack of a better term, what we'll call a generator that is designed to pull energy from heat or active braking, and then it converts that energy into something that's usable for the battery. Okay, those all have high voltage ranges on them. Okay. When we're doing shutdown procedures as extrication specialists, it starts with ignition interactions and power buttons. And then if necessary, your next step should typically be the 12 volt. You want to try not to cut cables. You want to try and remove cables. So if you need to re-engage 12 volt power to gain control over the transmission, you have that availability. Some manufacturers recommend manual disconnects on the high voltage battery packs. We categorically at the Energy Security Agency and in the OEM guidelines will tell you be very leery of doing that without proper PPE and proper training. Okay, that is one interaction directly with the battery pack where you can have an arc flash injury or get electrocuted if you use your open hand unprotected and touch the vehicle and the vehicle has become grounded. Okay, you want to make sure that you are not engaging with high voltage battery packs without very special guidance. All right, I'm going to give you 3 takeaway key moves on the extrication side. A-pillars. All right. We've skinned out the fender. We've busted the hinges on the front door, and we're getting ready to do a dash displacement. Be very conscientious about making just a blind cut on that A-pillar. In some of the EVs, they are actually channeling the high voltage cable through the rocker chamber and through the A-pillar chamber. That means even if I pull out the fender and take the mud skirt out, right, where I'm typically hoping to see the high voltage cable and say, I see it right there, I'll avoid it with the cut. If you just dig into an A-post and you have not identified where that high voltage cable is, there is a high possibility you may cut one. There is always stranded energy on the high voltage battery pack and on the high voltage cable, no matter what shutdown processes you do. So if you cut that, you are probably going to interact with 400 volts minimum. Everybody follow that? That's not going to be a desirable outcome. Other areas that you want to watch, the fender crush move, right? To gain access to the gap on the front hinge. If you go up and just blindly attack that wheel well with your spreader and go to crush down that fender wall, there is a good possibility that you've got an inductor conductor above that strut tower that's going to have super capacitors in it with 400 volts of energy on them. You crush that with your tool, you're going to have big problems again, right? And understand those aren't just energy problems. They may create short circuits within the system that are going to create short circuits within the high voltage battery pack, okay? Watch your floor pan movements. All the newer vehicles, the traction battery packs pretty much encompass the entire floor pan, right? So if I do any of my traditional load movements with rams or spreaders on the rockers or the floor pans, if you tweak the floor pan or the rocker panel and you apply pressure, there is a good probability you're going to be applying mechanical damage to your batteries, all right? So what can you expect if you mess up and do any of those things? A lot of stuff, okay? If you penetrate the floor pan and cause direct penetration to a lithium-ion battery, typically in about 15 seconds, you're going to get a high pressurized gas stream that is going to blow out of that enclosure. When it ignites, because it typically has enough ignition source, you're going to have about a 4,000 degree Fahrenheit blowtorch. It is going to continue to blow until it consumes the fuel within that cell or has expanded to the neighboring cells and then starts resulting in widespread thermal runaway and propagation. So direct damage is bad, okay? Second thing you can expect is a slow and delayed response. If you don't directly, really traumatically damage the batteries, and instead it's a submersion issue, or you've damaged another component that's causing a secondary internal short circuit, it may be hours, it may be days, or it may be weeks after you've done that event, and you will start developing off-gassing at a much slower release rate that then will eventually catch on fire. Last takeaway for you guys, and then I'm going to open it up to a couple of questions, and then we're going to close this out. When you are initially off-gassing, and everybody please get this, when you're initially off-gassing and the battery system has not created an ignition point and it's not on fire, that is the most hazardous time you can interact with an electric vehicle. So if as first responders you show up, it may look like airbag dust, residual dust from airbag deployment. Assume that that is electric vehicle potential thermal runaway. Your big indicator is cherry bubblegum. Everybody say cherry bubblegum. That's an odorant smell connected to the solvent within the electrolyte lithium-ion batteries. Tesla coined that term. I just say it's an electrical odor that's really, really sweet, okay? You'll always know it once you smell it. If you smell that odor, assume the battery packs are going into thermal runaway, walk away, right? Get your lines out on the ground and understand you're going to go in a different direction here, okay? Let's do some, hi, Keith, how are you, buddy? Let's do some quick questions because I blew a bunch of information at you guys really, really quickly. Anybody have any open questions that they'd like to ask in front of the group? If not, I'm going to step aside here once we're done. I'll be available over here, and I'll stay until nobody has any remaining questions. Any other inputs? Yes, sir.
If they cut the cable and the jaws are still on the cable, what's going to happen to the tool and the operator?
So the question was, if they cut the cable, meaning the high voltage cable, and it's the cut is conducted with a hydraulic tool or an hydraulic tool, that's your question, what's going to happen? You're probably going to create a massive arc, right? So this is just like using a metal component to interface with an energized metal component. You're going to have a radical electrified response that then is going to kick in a bunch of hopefully safety relays and fuses within the system, but the likelihood of arc flash and energy transmission is very high. Yeah, that could be a lethal choice. Any other questions? Okay. Guys, follow up with us. Check out our website, energysecurityagency.com, for more resources. All the ERGs and QRGs are on there for you, rescue specialists. We're collaborative with NFPA on hosting that library. Make sure you know what you're getting into. Make sure you understand the vehicles that you're interfacing. You can reach us through HURST. A lot of the HURST rescue specialists are very, very engaged and educated on these components. So rely on those guys as well for guidance and resources. And call us anytime. We have a 24-hour-a-day, 7-day-a-week hotline for first responders and tow professionals. It is free to all end users. You call anytime, any day, and you'll get a rescue specialist on the phone that will tell you how to safely interact with an EV and make sure that you're safe. EnergySecurityAgency.com. The number is 855-ESA-SAFE. It'll help you guys be safe out on the roads. Thank you very much for having me. Thank you, HURST. Thank you, Mike. Appreciate the time. And everybody be safe out there.
Thank you so much, Dalan. That was really, really valuable information. And we certainly want to encourage and can't stress enough the importance of education and ongoing education as it relates to electric vehicles. So thank you so much, Dalan.
We do it for those who run toward the fire. We do it for those who run toward the shattered cars and the broken buildings, to rescue the exposed and helpless. We do it because they deserve the absolute best. The most reliable tools and equipment that will provide them a reliably safe and successful mission. We owe it to them. We owe it to them to work together. We owe it to them to provide the best customer support we can, and to stand behind our brands and solutions the same way we stand behind the people who put them to use. And we owe it to them to constantly conquer technology, strive for innovation, and move the industry as a whole forward. Because when they are putting their lives on the line, they can't be worried about what's in their hands or flowing through the hose. It must deliver. And that is why we do what we do. And why we owe it to them to get up in the morning. Because if we don't, we fail. And we do not fail. We work tirelessly to make the fireground and rescue scene safer for all.